Today we're just going to review some things about trigonometry excuse me, from last year. And I want to begin with this simple formula, theta equals S over R. We use this if I have a central angle, theta, S is the arc length, and R is the radius. All right? But there's a very important thing. We used this last year. Note, theta must be in radians. It's very important. So what they're going to do, for example, is they'll say, all right, the angle is 135 degrees. That is theta. And the arc length is 8. What is the radius? All right? So the very first thing that you have to do is you have to convert this angle, theta, right here, you have to convert this to radians. So if you have forgotten, this is how we do that. I multiplied this by pi over 180. And then I can do my factoring, divide both of these by 45, and I get 3 pi fourths. That is my theta. And now I'm ready to use this formula, theta equals S over R. So, theta equals S over R. My theta is 3 pi over 4. They gave me the arc length to be 8. And then I just solve for R, which you can cross multiply to do that. 3 pi R equals 32. Divide both sides by 3 pi. And there's your radius, 32 divided by 3 pi. So you're going to have some problems like that. The next thing is to just, you're going to be working a lot with the graphs of sine and cosine. And I just want you to remember your parent functions, okay? And if you remember, sine does this, but we need to know more than that, okay? It keeps going like this. 1 period of pi is 2 pi. And it is broke up into these subdivisions that last year we called road markers, okay? Cosine also has a period of 2 pi. All right, so it looks like the granddaddy graph or the parent function looks like this. Okay, so if you remember last year, if I had a graph, let's say that my function was 2 sine of 4x. For example. Well, just to refresh your memory, we find the period by doing 2 pi divided by b. And b is this number. So I'm going to do 2 pi divided by 4, and that will be pi halves. But then we needed to find the road markers. So we always took this period and we multiplied it by 1/4. So the road markers are pi eighths. There's also an amplitude of 2. So when I get ready to graph this thing, my amplitude is 2, all right, and my road markers are pi eighths. So I'm going to count up by pi eighths. 1 pi eighths, 2 pi eighths, 3 pi eighths, 4 pi eighths, like that. And then we just fill in the dots. Since it is the sine function, I have a dot here, one here, there, there, and there. We called those the road markers, or sometimes they're called the quadrantal values. Now the other thing that I want you to remember is the possibility of a shift. You could have something like cosine of x minus pi. Well, at that point, that means that there is a shift right pi units. So in this case, my period is normal since I don't have a number here. So my period is 2 pi. The amplitude is normal. So we would sketch our normal cosine graph, okay? And remember, it normally ends at 2 pi. And this is pi, this is pi halves, this is 3 pi halves. Well, since there is a shift right pi units, every one of these points needs to get moved to the right pi. So this point comes to the right pi like that. And this point, okay, I'm going to go ahead and take the end and move it to the right pi units over to 3 pi. So there's my beginning and ending, okay. 3 pi halves, when it gets moved over, then I need to add pi to it, which means that would be the same thing as adding 2 pi halves. So it gets moved over to 5 pi halves. And then same thing here, this one would become 3 pi halves. All right, and then we can just kind of connect our dots. Okay, pi, this point would get moved over to 2 pi, and then we just connect our dots. That one's been moved to the right pi units. Now, the only other thing that I want to review with you right now is tonight in your book, they might give you something like this, give you a blank graph. And I'm going to put this in to a document so you can see it. They might give you a graph like this and then say, write the function, okay? And hopefully you can see my tick marks here, but I have 1, 2, 3 tick marks, okay? And then I have a, these break marks here. And I think they're going to say something like this is 6.28 and this is negative 6.28. Immediately you should recognize that as 2 pi. And this is negative 2 pi. All right? So if you notice, we have 2 periods of this sine function happening within 2 pi. All right? 2 periods took place, which means 1 period right in here is pi. Okay? So if a period is pi, okay, then we have to think backwards a little bit. Remember, the period is always found by doing 2 pi over b. So if the period is pi, then b must be 2. So if I'm getting ready to write this function, y equals sine, it must be y equals sine of 2x, and then the amplitude is 3. So they're going to ask you to work backwards from this graph to this function, and that's kind of how you do it. You have to think, okay, what is the period length that's going on? And then look at these tick marks. How long did it take it to do that period? All right? So we're going to stop there for today.